Hey guys, how's everything going? This is JSer. In this video, I'm going to take a look at 316, remove duplicate letters. To be honest, I didn't make it about this question. I tried for like 30 minutes and I couldn't find the solution. Something similar, but I didn't find the trick of it. And I take a look at the solution and finally understand it. So I rewrote it with my own way, and finally got it through. So in this video, I'm going to try to explain it as as simple as possible. Okay, I hope it helps. Okay, let's begin. So we're given a string which contains only lowercase letters. Remove duplicates letters so that every letter appears once, make it unique, right? And we must make sure that result is the smallest in lexicographical order among possible results, like B, C, A, B, C. Okay, first three letters are unique, and then we add B. So there are double B. So remove one. We can remove this B, but after remove this B, we could remove C here. Remove C here. We could get A, B, C, which will start with A. Comparing it to B, C, A, this is much smaller in lexicographical order, right? So we're doing that. About CBA, CD, CBC, it's technically the same, but ACDSB is the smallest in lexicographical order. So how could we solve this? For each LeetCode problem, I'd suggest that we dive into the examples and try to list up the iterations of all the steps and try to find a pattern or some nice trick. And we start with example 2. Obviously, it's much longer than the example 1, right? Okay, let's begin. So first we look at C, right? It's unique. And and we could just say, okay, this is the only one option, right? And then we got B, the same. Everything is unique. So here we already see that we could use, how can I say that B doesn't exist before, right? Okay, we could use a set actually. Use a set to keep track of all the letters. Unique. And then go to A, right? A is unique, so we add it. So we have CBA. Now we got C again. So this is a problem. We have C. We have also C here. So which one should we remove? Well, at first, I took a naive approach. I just compared that, okay, I will drop this C. Because if I drop this C, I will have a word starting with B, right? If I still keep this C, it will start with C. Well, the idea is right, but it is not right for the whole picture. Let's continue. Okay, CBA, C. Okay, so like the first idea of mine was, okay, two options. We could keep CBA, or we could just keep BAC, right? So C is bigger than B, so we'll drop it. So we keep BAC now. This is wrong actually. Only right for this small step. So let's continue. Anyway, and we got D, right? It's unique. Okay, we got C again. Again, C is smaller than D. We keep BACD, right? And then we got B again. B bigger than A, so we drop it. So we have ACDB. And then we got C. C is smaller than D. Of course, we keep this. So we got ACDB. It seems right to this example, but actually it's not. We're only changing one step, right? You see, only changing this letter. We drop all the possibilities of the right, but actually it's bad. For example, we have BCABC. What will happen? Well, we have B, C, A, and again B, right? B is smaller than C, so we drop this B, keep the BCA, right? And then we have C, and BCAC, and C is smaller than A, so we drop this C, so we have BCA. But actually we need ABC. If the easiest, the basic example doesn't give us, cannot be solved by our approach, so it's not right, right? So let's again take a look at the BCA to see why we're wrong. Okay, the first letter we got is B, and then we got C. Okay, so far so good, and A, so far so good, and now B comes, right? So for B, obviously this B cannot be used, right? If we start with C, it cannot be used this B. But actually, there's a trick. Is that actually these both BC could remove because finally we're going to choose ABC, right? We're going to remove this B and remove this B. Just keep the rest. So what's the problem here? The problem is actually if we consider B, we do nothing. But if we consider in C, right? If we consider in C, there is another C at the end, actually, after this B, right? After this. So, and C is bigger than A. C is bigger than A, and there is another C after this A. So why not we just choose the latter one, right? So this gives us a hint that when we add A, right? C is bigger than A, and there's a C after A. Then we should remove this C to keep it like BA, right? BA. And then there's a BA. B is bigger than A. There is a B after BA. So we don't need this B, right? So we could shrink it to A. And now we have ABC. So this just is a small step to lead us to the final solution. Let's consider some letters, okay? Let's say is some letters like we don't know what it is. So if it's ascending in lexicographic order, so it's the smallest, right? This smallest. The only thing that we could improve this, only chance we could improve the list is that there must be some letters going downward, right? Is that there is some downward slope. Suppose I and J, and the SI is bigger than J, so this is downward slope, and there is another SI after SJ, right? If there is no another SI, it means this is unique. We have to keep it. The position cannot be changed, so we cannot improve. This is the only case we can improve, right? So we actually find in the negative case, the opposite of this problem. And so our idea is just to remove these opposite cases, right? Possibility. So this is a general idea. Let's go back to our BC ABC case here. So, okay, we're going to B. Let's review it once more. We get B. Okay, now we have C, right? C is bigger than B. And we do nothing. And then we go to A. C is bigger than A. And we have to know whether there is another C after A, right? For that, we could just count the numbers, right? And we know directly whether there's a C after A. Okay, we know now there's a C after A. We should pop it, right? We should remove it. And now we're comparing B and A, right? B is bigger than A. There's another B, so we got A, right? So typically, this is a stack. We hold B and C, and now when we're going to push A, we will check against the top elements and pop them. And then finally we pushed it in, right? So now we have A. And then we got BC. It's not there with B, and then we got C, right? So this is it. So this is our approach. We need to pre-count the numbers and use a stack, keep track of the letters. When we are handling new letters, we compare it to each element, And if we found it is bigger than it and has a future numbers, we remove it, and that letters will be pushed in the future, right? So that gives us the smallest one. Okay, so now let's start our code. But first, we need to count the numbers, right? It's simple. We use a count map. Okay, we have counted, and now we need to use a stack to keep track of our optimal result, right? In array form, we just say this is okay. We use a stack, and then we will loop through all the what it is, the letters. Okay, S. And besides, we need to use a set right here to keep track of all the letters, to check it instantly about there is a duplicate or not. So okay, this is a, let's say, result stack. This is a result set. Okay, first one, if it doesn't have this number, if it is already in, what happens? Okay, if it is already there, let's see. We haven't seen this case yet, right? Suppose we have like a B, C, A, and then we got B. Okay. Wait a minute. So this ascending, right? So something A and B and C. Now we have C again. Okay, maybe not. We have A again. What happens? Well, we we check that C is bigger than it. We update it. We still do the same, right? It doesn't matter whether this letter is in it or not. If it is have it, B. We pop B, C, and we stop at B. So when do we push it in? Well, there might be some duplicates. So actually there should not be any duplicates actually. If you remember that if there's a B here, if there's a duplicate case, actually if this B could be switched to this B, it is already handled when the first B is input, right? It is pushed, it is kept there because this B cannot be switched to this B, right? We'll do it from the first empty and then second one. So it means when we handle A and B and C, it's okay. So now we have B, we cannot switch. If can, like there's something bigger than B. Wait a minute. There's something that means there's something smaller than B in this array, and that could be done much sooner than this B arrives, right? So we cannot switch the B. So we only check if it exists or not. If it exists, we just skip. So we only handle when it doesn't have this letter. As we analyze, what should we do? We'll keep popping the element and compare it, right? So we see get the elements. Okay, we might there's a case that we don't pop anything, so we just compare with the top element first. While we result stack is not empty. Top, we don't pop it yet. Okay, so if this element is smaller than the character, then it means we should stop, right? So if it is smaller than our character, or if it is bigger than it, but there's no, so this condition should be the opposite of the case here. So if it is smaller than it, or there's no number, no duplicates after our character, so which means the count map, it gets the top is 0, right? If this is the case, then we should stop. We stop here. There's no more need to go to the previous letter. Letters. If this is the case, we break. Right? Yeah. And if it is not the case, we should pop it, right? We pop it and doing it for next one. So we pop it. When we pop it, it means the set should be also be updated. So we delete the top. Okay. So and after this, when everything is ready, we will push this character in it, right? Okay, we push character, and then result set add character. Yeah, there's another case. Don't forget that we loop through all the characters. This count should be updated also. So count map set character count map get character -1. So this is it. Finally, we get to the result stack. We will return result stack and join it. Let's see. Great. Let's see what actually the intermediate stack for this input. Okay, to make it clear. Okay, let's log the result stack and the results count map. Okay, so now we have C, right? And then we got B. C is bigger than B, and there's another C after B. So this stack, we want to use the first C. It's not optimal, so we keep only B in it, and updates the count of C to 3, right? The first C was 4. Okay, we now B. Now we met A. B is bigger than A, and there's a B after A, so we stop using this B. We only keep A. So the B updated with 1. With the there's something wrong with the count. Our push B here becomes 1. There's something wrong here, I think. Anyway, the stack is right. C is 4, B is 3. A is 1, D is 1. We got 2. B is 2. Yeah, right. It's CBA, DBC. Okay, now we A, and then we got AC, it's ascending, ACD, ascending, D now is 0, ACD is, and then ACDC. C is already in it, so there's no need to do anything. And we got B again. B, D is bigger than B, but there's no D after it, so we do nothing. And then C is already in it, so we get ACDB. What happens for the first one? This might be more interesting. Okay, first we got B, and then BC, right? Ascending. Now A. C is bigger than A, there is a C, so we stop using C. B is bigger than A, there's a B, so we stop using B. We keep A, and then A, B, C ascending. Yeah, this is shorted. So, I think this is a pretty interesting problem, but it's not that easy. I didn't make it, and okay, let's analyze the time and space for this one, okay? For the space, actually we use a map, and a stack, and a set. Yeah, this is generally, it should be linear time. Or linear space, I'm sorry. 3n, it's linear space. And this is time. What is the time? Okay, this is linear time to count. And this is a linear time to iterate, and the set is constant, and this will be, I think, so the maximum of the set is actually Okay, this is maximum actually 26, right? Letters. This is 26. And this is 26 actually. So we will say this actually is 26. It's typically constant, I think. Okay, and this here, still this is constant. Even though there's a while loop, there were maximum 26 numbers, right? Letters. And then we do it, and for as, so yeah, it's constant times 26, right? So it's linear time. Cool, that's it. Hope it helps. See you next time. Bye bye.